All right, welcome back. Today we're going to introduce three variable systems, and this is going to be a pretty big day as far as kind of getting your feet set for what's coming up involving matrices. I want you to be observant to the fact that in these two equations, these little areas right here have missing gaps. Now that's going to be important when we get to the matrices, because what we're doing is we're going to introduce something called row operations in preparation for reduced row echelon formats. And this is what you're doing when you reduce row echelon format, when you're dealing with the matrices. So notice that the x value in this case is 0. The x value and the y value here and here are both 0. I'm just giving you a little preview. We're not going to touch that today. That's not going to be anything we address. I just want you to be observant to it so that you can make that connection later this week when we go over this again in the matrix. All right, so using substitution, this becomes a very simple problem. We simply go to the bottom and we work back up to the top, which is why reduced row echelon format works. It's just the operations that get to it that are a little bit tricky. So if z equals 4, I'm going to substitute that into the previous equation. Y plus 4 equals 7. Solving for y, I get y equals 3. I'm going to take these two combined solutions and I'm going to plug them into the first equation. So x plus 3 plus 4 equals 12. X plus 7 equals 12. Subtract 7, and I get x equals 5. Now make sure that when you're doing this, you're neat and organized so that we can clearly see what your solutions are. So I'm going to go ahead and build on this last solution. Y equals 3, z equals 4. So that is my solution. I'm going to go ahead and box it like that, and now I'm ready to move on. Okay, over here, we've got to do a little bit of work. It's not just going to be a give me here. So we're going to do 3, divide both sides by 3, gives me z equals -1. We're going to go ahead and plug that one in up here, and I get 2y minus a -1 equals 7. Minus a minus makes a plus, so I'm going to subtract 1 to both sides. 2y equals 6, divide by 2, and y equals 3 is my second solution. Now I'm going to come back up here, and it's going to be 2 times x minus 3 plus 3 times -1 equals -2. So I get 2x minus 6 equals -2. Adding 6 to both sides gives me 2x equals 4, divide by 2, x equals 2. Again, please be organized in the way that you present your solution so that it is easy for us to see what your solution actually is. All right, the big part about these is your ability to read, interpret, and understand word problems. This is the key to actually doing test questions properly, because the majority of the test questions we present to you are going to be given in word problem format. So please read and interpret what you're looking at properly. It can be a little bit confusing, so let's go ahead and look at some of these keywords together. The sum of 3 numbers. Well, I need 3 variables if that's the case, so I'm going to go ahead and use x, y, and z. The sum is addition, so x plus y plus z equals -4. And now I'm going to go ahead and start to interpret what's going on. The second number decreased by the third number. Okay, so let's start there. The second number I've created is y. Decreased by the third means minus z. And then here's my keyword here that tells me I'm moving on to the other side of the equation, is equal to the first. So that's going to give me that. The next step I'm going to do is follow on to the third. Remember, typically when there are 3 variables, there are going to be 3 equations. So just keep that in mind when you're looking through these word. All right, so the sum of the first and second number, so that's going to be x plus y equals -5. We're asked to find the product of the 3 numbers, so let's go ahead and find those 3 numbers now. This one's a little bit more tricky because you'll see at first glance that it really doesn't have what you need in order to just simply plug one into the next, plug the next one into there, and keep on going all the way through. However, if we go ahead and take a look at the problem from a different point of view, we can solve this thing pretty easily, okay? So the first thing I want to do is I want to look at the fact that x plus y is the number -5. I'm going to look around in all of the other equations and I'm going to find the place where x plus y is located. So there it is. Now what I'm going to do is I'm going to substitute -5 for x plus y. This is actually an SAT type of problem. Then I'm going to add 5 to both sides, and that's going to give me my value of z, which is -1, or +1, sorry. I left off that negative before. Now I can go back and I can plug in and find the rest of these values a little bit more easily. I'm going to address this by looking at this particular problem right here and solving it for y. Because what I can do here is I can take this and plug it into the second equation and it's going to give me a single value. Because everywhere that I see z, I can change it to the number 1. Now this becomes a bit like a puzzle, so you got to kind of piece it together so that you can see what you're looking at. All right? So notice if I take this and move the x to the other side, I get y equals -x minus 5. I can take y equals -x minus 5 and I can substitute both the y value and the z value into the second equation and it's going to give me this. -x minus 5 minus 1 equals x. So now what I can do is I can move my x's to the same side, adding x here, giving me 2x, combining my like terms, -6 equals 2x, divide by 2, and now I get x equals -3. Now all I need to do is plug it back in one more time to that same exact equation, and that's going to give me what I need. Okay? I'm going to go ahead and take -3 equals y minus z, and in this case z equals 1. Add 1 to both sides, and it gives me y equals -2. Now this one is a little bit tricky, so take a look at it and see where it is that we're getting all of this information. If you have any questions about it, make sure that you're asking them, because it, like I said, it's a bit of a puzzle and you got to piece it together one piece at a time. All right. First things first, the triangle has a perimeter of 65 feet. That means that L plus N plus M equals 65. The next thing I'm going to do is I'm going to take a look at each one of these individually. I notice here that if I substitute L into here, I get an equation which only has M's in it. So that's my first step. N equals 1/3 M, because I'm substituting here, plus another M minus 15. And now what I see is that if I substitute into this equation this, this, and this, I now have an equation which has one single variable in it, and that variable is m. Notice what I do here is 1/3 m plus m plus 1/3 m plus m minus 15 equals 65. Now we get here 1/3 plus 1/3 is 2/3, so we get 2/3 m plus 6/3 m, that's going to be m plus m is 2 m's, minus 15 equals 65. Then I combine these like terms, 8/3 m equals, I'm going to add the 15 to the other side here, equals 80. Multiplying by the reciprocal, we don't divide fractions, multiplying by the reciprocal gives me 10 times 3, which is 30. So m equals 30, L equals 10, and N equals 25. I simply found those by plugging them back in again. Let's go back up here and finish this problem. I've neglected to solve what was being asked of me to solve, so let's just go ahead and multiply these together. 3 times 2 makes a positive 6, and then 1 makes that, and our solution to this problem is 6. All right? Please take a look at these again. If you have any questions, don't hesitate to ask. They can be a little bit confusing when we move around throughout the video. All right?